Memories stored in the hippocampus. My key arguments for the idea that the hippocampus is a place where memories are stored are as follows. When damaged or removed, there is a significant impact on the ability to form and store new memories. Sleep deprivation impairs long-term potentiation in the hippocampus, leading to impaired memory function and storage. And finally, that Alzheimer's disease progressively breaks down the hippocampal region, which results in loss of effective memory processing and storage. All of these points lead to the conclusion that the hippocampus is a crucial storage site for memories. My first piece of evidence is related to the effects of damage to the hippocampus and how it leads to extensive memory loss and malfunction. This is a widely studied topic with extensive testing. One of the first cases to show this was that of one Henry Gustav Molaison, colloquially known as HM. He had parts of his hippocampus removed during an operation to treat his epilepsy. However, post-op, it was revealed that he was unable to form new episodic memories, with new ones lasting only up to minutes. This provides a basis in which to say that the hippocampus plays a crucial role in the consolidation and storage of declarative episodic memories. Further studies on this topic have shown that mice that have their hippocampuses removed in the same manner as HM had poor recollection retention, as well as delayed reaction to stimuli they had previously been exposed to in a lab. Studies have also shown that the hippocampus not only has a role in providing context for episodic recollection, but also the object of the memory. It is previously understood that various cortical pathways in the medial temporal lobe of the brain in which the hippocampus is located had specific functions in recollection. However, additional study has shown that there is a lot more overlap than was previously understood, and that the hippocampus actually has much broader function in storage and recollection of episodic memories. Sleep provides essential reparative function for the brain, as well as crucial consolidation time for the brain to process and store new long-term memories. It is believed that this happens during slow-wave sleep, somewhat later in the sleep cycle. The hippocampal region is an essential place for long-term potentiation and a prime time for this to occur is during sleep. It is then logical to predict that sleep deprivation has a negative impact on the long-term potentiation, consequently leading to the impaired storage of memory and recall. In a study conducted by scientists, rats were deprived of sleep for a period of time before undertaking memory tests that they had previously already undertaken and having the hippocampus sliced and examined. The results revealed that their long-term potentiation was disrupted. This was seen through analysis of neural bundles in the hippocampus. The mice's recollection during tests was interrupted because their neurons did not have ample time to go through long-term potentiation, and thus adequate storage of their memories could not take place. This is further evidence that the hippocampus is an integral place where memory storage takes place. My final piece of evidence involves the neurodegenerative disorder Alzheimer's disease and its progressive breaking down of hippocampal function, resulting in loss of memory processing, as well as loss of episodic memory. Newly formed DIN8 granule cells, pictured below, have highly productive and increased synaptic plasticity, allowing for high levels of long-term potentiation to occur in the hippocampus. A factor in the proliferation of the disease is the brain's inability to continue producing these cells. Reduction of these cells result in disrupted hippocampal dependent tasks. As the structure of the hippocampus is further affected by the progressive degeneration of neurons, a subject's ability to form new long-term memories is destroyed. Those affected by Alzheimer's disease will develop poor spatial memory, as this is another primary episodic memory stored in the hippocampus. The evidence provided in source 1 is probably the strongest for my contention. This is largely held by the fact that damage to the hippocampus and the subsequent ill effects that it has on memory has been studied for decades and has the most extensive reports. My first source covered human beings as well as animal research reports, which provided me with more broad background. The evidence for source 2 is good in that it provides proof for my contention, but has the disadvantage of not being explicitly linked to it. The report is on sleep deprivation and long-term potentiation, which is something I have to remember to link strongly to the role of the hippocampus. The evidence is there, but what I was able to draw from the study to support my contention wasn't directly what was being studied. It was a bit of a volatile source. The evidence from source 3 similarly backs up my contention the way source 1 does. This is by studying the damage or removal of the hippocampus and the direct link that this has to impaired storage of memories. The evidence provided clearly links the hippocampus to the storage of episodic memories. This is proven by the various studies done on those who have the hippocampus damaged or removed, whether it be by surgery such as HM or neurodegenerative disease such as Alzheimer's, and the subsequent effect that this has on the formation and consolidation of memories. The effect of sleep deprivation on long-term potentiation in the hippocampus furthers the idea that this structure plays a crucial role in memory storage. However, not all types of memories are stored in the hippocampus. The evidence provided in this presentation exclusively focused on aspects of episodic memory, as different types of memories are stored in different areas of the brain. That being said, it is undeniable that the hippocampus stores episodic memories. And there are my sources, references. Thank you.